Hey guys, this is my video on the superposition principle of circuits, and we're going to use this method when we have two or more batteries or currents. All right, so there's four main steps. The first step is going to be to redraw your circuit by breaking it up into smaller circuits without including the battery for each one. The second is going to be to draw the direction of current flow. The third one is going to be to solve each of those individual circuits like a normal series parallel combination. And then the fourth step is going to be to add or subtract the currents and voltages based on the direction of current flow. All right, so I'm just going to hop right on in. Here's our first problem. Now, for our chart, we have our R's right here, and then we have these two columns are the current and voltage for the first circuit. This is the current and voltage for the second circuit. And then these last two are for when we add or subtract the currents and voltages. Like always, we have an equivalent resistance for each circuit along with the total current. So this first problem, let me look for my pen. For this first problem, I'm going to break this down into its two different circuits. So the first one, I'm going to have this battery, but I'm not going to include that one. So this is my 35-volt battery. And then I have my first resistor, which is 30 ohms. Then I have R2 and R3. I'm not going to draw that battery. I'm going to leave that one out, remember. And then I'm going to have R4, which is 40. So I have R1, which is 30. R2, which is 20. R3, which is 10. And R4, which is 40. Let me go ahead and add those in my chart. So I have 30, 20, 10, 40. And this is going to be for a 30-volt battery. So let me just add my battery right there. Now, the second time I draw this, I'm going to include this battery, but I'm not going to put this one in. So I'm not going to include my 35-volt battery. But I do have all my resistors. Now, this is R1, which is 30, R2, which is 20, R3, which is 10, and then R4, which is 40. Sorry for my really messed up circuits. Now, let's solve this one first. So the first step I'm going to do is simplify and find REQ. Combine R2, 3. They're in series because they're on the same wire. So 10 plus 20 is 30. So I'm going to have my R1, which is 30. Now I have R2, 3, which is 30. And I have R4, which is 40. So R4 is 40, R2, 3 is 30, and R1 is 30. Now, what I want to do, and this is for 35-volt battery. Now what I want to do is combine R2, 3 and R4 in parallel because they are on different branches. When the current hits this point, it's going to split. Some of it's going to go this way, some of it's going to go that way. So we have multiple paths of current flow. So have R1 just sticking around. Then I'm going to have R2, 3, 4. I have R1, which is 30. Now, to combine those in parallel, I'm not going to do, remember, I am not going to do 40 plus 30. I'm going to do 1 over 1/30 plus 1/40. And when I do 1/30 plus 1/40th. I'm going to get 17.14 ohms. And then my last step is going to be to combine these in series because they're along the same wire. What goes through R1 goes through R234. So, I have one resistor now. So 30 plus 17.14 is 47.14. So R1, 2, 3, 4 is 47.14. Let me go ahead and add that in my chart. 47.14 is REQ. Ooh. Let me go ahead and cross out R5 because we don't have a fifth resistor in this question. All right. Now, time to work backwards, the hard part. Now, ask yourself, how did I combine this resistor together? So looking at my previous picture, I combined R1 and R234 all in series. So if they're in series, my current here is going to match this current and this current. So the question is, how do I find my total current right here? Well, my total current is going to be equal to the voltage, which is 35, divided by 47.14. That's going to give me 0.74 amps. That means right here is 0.74 amps. Right here is 0.74 amps. And this is really nice because that means R1 gets 0.74 and R234 get 0.74. But the only one I can add in my chart is for I1 because it's not being split with anything. So I1 is 0.74 amps. Now, what about 234 though? Well, looking at my previous picture, I combined those in parallel. So if I combine those in parallel, the voltage right here matches these two voltages. So the voltage right here is going to be IR. What's the current going through here? 0.74, because I just found that, times the resistance, which is 17.14. 0.74 times 17.14 gives me 12.68 volts. And since they're in parallel, this means 12.68 volts right here, but these two are also 12.68. So when I do that, I notice R4 is by itself. So that 12.68 volts goes all to R4. Now, but what about 2, 3? Well, how do I combine 2 and 3 together? In series. So if I combine them in series, that means they have the same current. So the current right here matches these two currents. So the current right there is going to be equal to V over R. My voltage, which is 12.68 for that branch, because I just found my voltage for that branch. 12.68 divided by the resistance. So R23 is equal to 30. .42 amps. So that means R2 gets 0.42 amps, and then R3 gets 0.42 amps. So let me add those in. 2 and 3, 0.42 amps. Now for the rest of this, I can just solve this by using Ohm's law. V is equal to IR. So I'm going to do 30 times 0.74, and I get 22.2 volts. 20 times 0.42 is 8.4 volts. 10 times 0.42 is 4.2 volts. And then 12.68 divided by 40, because I is equal to V over R. V over R gives me 0.32 amps. Cool. Now, oh, I never put my current right here, 0.74 amps. All right, time to solve this circuit. Looking at this circuit, series parallel combination. Rewrite it. First thing I want to do is combine my series circuits, 2 and 3. So here's R1. That's going to be 2, 3. That's R4. This for 40 volt. So R1 is 30. R2, 3 is 30 because 20 plus 10 is 30. And then R4 is 40. All right, step 2. Step 2 is going to be to combine R1 with R2, 3. Because if I look, the current's going to flow, but it's going to split. Since the current splits, they have 2 different paths. So that means this R1 and this R2, 3 are in parallel with each other. So when I combine R1 and R2, 3, I have my 40 volt battery. I have R4, which is 40. And I have R1, 2, 3, which is not 30 plus 30, but it's going to be 1 over 1/30 plus 1/30, which gives me 15 ohms. And then for my final picture, I'm going to combine R1, 2, 3 with R4 in series because they're on the same line. What goes through here is going to come around and also go through there. So R1, comma 2, 3, comma 4 is going to be 40 plus 15. So 40 plus 15 is 55 ohms. So REQ is 55 ohms. Now, current. So since I combine these in series, my current here is going to match these 2 currents. So let me calculate my current here. My total current is going to be V over R. V is 40 divided by 55, which is going to give me 0.73 amps. So R4 gets 0.73 amps. And then I1, 2, 3 is going to get 0.73 amps. Since R4 is by itself, I can put that 0.73 in for I4. I can't do that for 1, 2, and 3 because they're not alone. So for I4, 0.73 amps. And that's also my total. Now, what do I know about 1, 2, 3 though? I combine those in parallel. So the voltage here matches the voltage here and the voltage there. So my voltage is going to be equal to IR, which is my current there, which is 0.73, times that resistance. So the resistance right here was 15. So 0.73 times, my calculator's off. 0.73 times 15 gives me 10.95. So that means this is 10.95 volts. So 10.95. And then 10.95. Now, if I look, R1 gets 10.95, R23 gets 10.95. Since R1 is by itself, I can make my V1 be 10.95. So V1 is 10.95 volts. So the next question we have to ask ourselves is, well, for R23, how did I combine those? I combined those in series. So since I combined them in series, the current here matches the current here and here. So my current is V over R, which is my voltage, 10.95 volts, which I just calculated for there, divided by my resistance, which is 30. If I do that, I'm going to get 0.37 amps. So that 0.37 goes to 2 and it goes to 3. 0.37 times 0.37. The rest of this is putting in your calculator. I is equal to V over R. V is equal to I times R, I times R, I times R. So when I do all of that, I'm going to get 0.37 amps, 7.4 volts, 3.7 volts, and then 29.2 volts. Almost done. So now, let me draw my currents and see which directions they're moving in. All right. So when I draw my currents, guys, I always go from the positive end of the battery to the negative end of the battery. The positive end is the longer side. So the long side of the battery, sorry, this one is very poorly drawn. The long side to the short side. So it's going to go up here, go through there, but at this point it's split, so it's going to go down. Some of it's going to go this way and keep on flowing around. Then it's going to meet back up and go up here. That's how my current flows in that one. For this one, it's going to flow up, go this way, then it's going to split. Some of it's going to go down, some of it's going to go this way. All right. So this is my current flow. Now for R1, for the first circuit, it's going to the right. See? Arrow going like this. For the left, through R1, it's going to the left. They're going opposite directions. If they're going opposite directions, let's subtract these and take the absolute value. So do 0.74 minus 0.37, and you get 0.37. So that goes right here for both. This is the overall impact R1 feels. 22.2 minus 10.95 is going to give you 11.25 volts. So that's the overall, the combined effect. Now for R2, looking down here, for R2, it's going, the current's going down. Over here for R2, the current's going down. So they're both going down, down, same direction. So I'm going to add 0.42 plus 0.37. I'm going to get 0.79 amps. And I'm going to do 8.4 volts plus 7.4 volts to get 15.8 volts. Now, R3. Looking at the first circuit, R3, it's going down. For this one, it's going down. So down, down, add 0.42 plus 0.37. Gives me 0.79 amps. 4.2 plus 3.7 gives me 7.9 volts. Then R4. It's going down for R4 in this one. And it's going up for R4 for that one. So this one's going down, this one's going up. I have to subtract. 0.32 minus 0.73 is negative 0.41. But remember, I use absolute value to make it positive, so 0.41 amps. And then I have 12.68 minus 29.2, which is, after absolute values, it's going to be 16.52 volts. So this is how we do the first superposition problem. I know it's super long, guys. I'm sorry.